thing here is with ionic bonds, we were transferring electrons. That's what was holding it together. Covalent bonds share electrons. And we mentioned earlier that these are much stronger bonds because they're sharing them. And there's actually three types. So we have single bonds, double bonds, and triple bonds. Okay, single bonds share 2 electrons, and those are pretty common. Those are the most common ones. Double bonds share 4 electrons, and triple bonds share 6 electrons. Triple bonds are going to be our strongest because they're sharing the most electrons. So it's very difficult. It's kind of like if you're building a fence. If you got a fence right here, if I put it in one post, that might hold it up. It's not extremely strong, but it's going to hold your stuff in place. Put a double bond in there between these 2 fence posts. That's going to hold it pretty strong. And if I put a triple bond, that's going to be a very strong fence. It's going to be difficult to break it down, and it's going to last a lot longer. So we've got that. So when we draw our bonds, what we have to do is we go through something called have and want. Wants 2 valence electrons. Want 8 valence electrons that we will work with. So we go through something called have valence electrons and we want valence electrons. So let's just take a look at some of our examples that we looked at the beginning. So let's start with H2O. So we got H2O. So what we're going to do is when we solve this, we list every single element. So I've got 2 hydrogens and 1 oxygen. Okay, if I come here, hydrogen has 1 valence electron. It's in group 1, so it only has 1. So I'm going to go ahead and mark that down for both of them. Hydrogen wants 2 valence electrons. So I'm going to list that right there, here on this side. The next one we've got is oxygen. It's in group 16. So it has 6 valence electrons, but it wants 8. So the next step is we're going to add these up. So I got 6, 7, 8. 8, 10, 12. So we've got that. From there, I'm going to go 12 minus 8 gives us 4 electrons. That's how many we're going to share. And because we're sharing this, I'm going to divide it by 2. And it tells me I'm going to have 2 lines when I draw this out. So now when we draw this, I want to make it look kind of like a teeter-totter. I want it as balanced as possible. So I've got 2 hydrogens and 1 oxygen. So I'm going to put oxygen here in the center. And then on each side, I'm going to put hydrogen. And everything has to be connected with 1 line, like this. So each line equals 2 electrons. So hydrogen right here has 2 electrons. It does not want any more, so it's done. This hydrogen wants 2 electrons. It is now done. Now if I go look on oxygen right here, I've got 2 electrons and 2 electrons with the lines right here. So I'm just going to kind of make a little note here saying how many we've got. So right now I've got 4 electrons. What I do from there is I put in dots for my remaining electrons. So I've got 1, 2, 3, 4, 5, 6, 7, 8. I got a total of 8 electrons right here. That's what oxygen wants. And right here, hydrogen has 2 electrons. That's what it wants. And this hydrogen has 2 electrons. So that's exactly what we want. If you want to see what it looks like with the actual valence electrons, I'm going to put oxygen's electrons in blue. And then I'm going to put hydrogen in red. So you can see that we're sharing electrons right here. Those are being shared, and those are being shared. So this would be our line. And this would be our line. And then we're just showing dots to show that we've got our 8 valence electrons. So that's kind of a simple way of looking at it. So let's do a few more of these. Next one we're going to right. So we're going to do our have and our want. Again, this is valence electrons. And I'm going to so for phosphorus, It's in group 15. It has 5 valence electrons. It wants 8. Hydrogen being in group 1 only has 1. But remember, hydrogen only wants 2 valence electrons. So from here, let's add up each side. So we've got 5, 6, 7, 8. On this side, we've got 8, 10, 12, 14. From there, I'm going to take the 14, subtract my 8. That's going to give us 6 electrons to share. I'm going to divide that by 2, which means I've got 3 lines. From there, make it like a teeter-totter. So I'm going to put phosphorus in the middle, because that's kind of where I can teeter-totter it. I'm going to put a hydrogen on each side. And then I've got 2 here, and then I've got 1 extra one to put. So I can put it here on top. I could also put it down here on the bottom. It really doesn't matter where. So now the last thing I need to do is go and check, see if I need any dots. So again, this line represents 2 electrons, 2 electrons, 2 electrons. So hydrogens, each one of those is good. And they will never, ever have more than 1 line. I can't form a bond here on the side of it. So if you ever get a bond with with 2 lines off of hydrogen in any direction, it's wrong. This is it. It has to be on the outside. So I've got 2, 4, 6 electrons right now for phosphorus. I need to get 2 more dots to make it go up to 8. So now I've got 8 valence electrons, and everything's pretty happy. All right, let's try another one here. Let's do carbon dioxide. So we're going to do our have and our want again. Carbon has 4 valence electrons because it's in group 14. It wants 8. Oxygen has 6 valence electrons because it's in group 16. It wants 8. So I'm going to add these up. So I've got 12 right here. Plus 4 will give me 16. And then 3 times 8 will give me 24. So I'm going to go 24 minus 16 will give us 8 electrons. I'm going to divide that by 2, and that tells me I've got 4 lines. All right, so let's make a teeter-totter. Carbon's kind of by itself, so that one should go in the middle. And then I'm going to put oxygen here on each side. So now, to connect this, I've got 2 lines right there. Problem is, I've got 4 total lines I need to draw in. So I can't just put a random line going up and down. It has to connect to something. So I'm going to connect one right here. So I'm up to 3, and to make it like a teeter-totter, I'm going to connect it right here. So now this is balanced like a teeter-totter. So let's look at this. Each one of these lines is 2 electrons. So now I've got a total of 4 electrons right there. So I've got 4 electrons. And then oxygen wants 8, so I've got to put in 4 more dots. So that'll give me 8 electrons total there. I'm going to put 4 over here because we know it's going to be the same thing. Now if I look on carbon, I've got 2, 4, 6, 8. I've got my 8 electrons. I do not need any more. So that's how we would do carbon dioxide. Okay, let's look at. So this one will be a quick one, but a little more difficult to draw. So carbon, I've got 4. It wants 8. Oxygen has 6. It wants 8. So I've got 16 here, 10 here as far as electrons go. I'm going to subtract those. 16 minus 10 will give me 6. Divide that by 2 gives me 3 lines. Everything has to be connected with at least 1 line. I've only got 2 elements, so carbon and oxygen right there. And then I start adding in extra lines until I'm up to my 3 lines. So I've got this right here, a triple bond. Very, very strong bonds. And 2, 4, 6, so I need to put 2 dots right here. 2, 4, 6, I need to put 2 dots right here. So now I've got my triple bond there. So this bond is much stronger. If you think about a fence, very strong fence compared to carbon dioxide, which has 2 double bonds. All right, okay, let's look at one more. C2H2, so dicarbon dihydride. So we've got our haves and our wants. So we've got carbon, carbon, hydrogen, and hydrogen. So we've got 4, 4, 1, 1. That's what they have. Carbon wants 8. Again, hydrogen only wants 2. So we're going to add these up. So I've got 8, 9, 10. Over here I've got 16, 17, 18, 19, 20. So I'm going to take 20 minus 10. Gives me 10 electrons. Divide that by 2 gives me 5 lines. So let's make this like a teeter-totter. And remember, carbons have to go in the middle because hydrogen has to go on the outside here. So I'm stuck with something kind of like that. Now when I draw this, I've got 3 lines, but I need 5. I cannot put a line onto hydrogen, because hydrogen's full. I can't put any more here. So I can put another line here, so now I'm up to 4, put another line up there, so I'm up to 5. So now if I were to draw a dot, hydrogen, there's 2 electrons right here, hydrogen's good. Come over here, this hydrogen's good. So if I look at just this part right here, I've got 2, 4, 6, 8. That's what that carbon wants. And now if I look on this carbon, 2, 4, 6, 8, that's what that carbon wants. That is your final bond for that one. So that one was for dicarbon dihydride. So the process is basically the same. You just kind of have to think about doing the teeter-totter, making it balanced. And remember, only one line for hydrogen. There will never, ever be any more. And that is the end of this. Thanks.